Today's topic is electrical potential energy and electric potential. Potential energy and potential both will be due to source charge. So, first of all, we should try to understand what is electrical potential energy. It is the amount of work done in bringing any charge from infinity to any point inside the electrical field of the source charge. We'll try to understand with the diagram here first. Let us take, we are taking any charge Q here at O. This is a point charge and we are finding your electrical potential energy due to point charge at any point. So let us take a source charge Q at O, and from O far away from it, let us at infinity a charge Q naught is there. If we are bringing this charge Q naught from infinity to any point P, which is inside the electric field region of this charge Q, then whatever the work done, the Q naught will perform in bringing from infinity to P, that will be called as potential energy of P point. Let the point P is at a distance of R from the source charge Q. If you are bringing this charge Q naught from infinity to any point P inside the field of or inside the field region of Q, then that work done will be called as potential energy, and this potential energy at P can be referred as capital U at P, potential energy at P. This is also equal to work done for charge Q naught from infinity to P, and its formula will be 1 by 4 pi epsilon naught source charge test charge by separation of the point or the distance of the point from the source charge. This is the formula for potential energy. You are observing that this is the work done, so its unit will be in joule. We will find out the expression for potential energy later on. First of all, understand what is basically potential energy. Now, if you are bringing any charge Q naught from infinity to P, from infinity to P, it is called potential energy. But if you are bringing the charge of unit value, then the same work done will be called as electric potential. That means, how to define electric potential? It is the amount of work done in bringing a unit positive charge from infinity to any point P inside the field region of source charge Q. So, if you are bringing any charge or any unit charge, then that work done from infinity to P again will be called as potential of that point. The formula for it will be this one. This means you are observing that electric potential is nothing but it is the work done in bringing any charge from infinity to P divided by whatever the charge you are bringing. So when you are dividing it with this automatically becomes for unit charge. That's why this work done will be for unit charge. To obtain expression for potential energy or electric potential at point P, let us draw 2 points. We are taking a point Q very close to P. Let the charge Q0 is somewhere at P or somewhere at Q. What will be the electrical force acting at that point? As we know, 1 by 4 pi epsilon naught will be equal to this much, and the direction will be radially outward. Radially outward because this one is positive charge, so it will be towards, the direction will be away from it. So you may write the direction is OP produced. Either you can say radially outward or you can say OP produced. This is the vector quantity. Point Q is very close to P. So since P and Q are very close point, so electrical force or electric force due to Q at P or at Q will remain same. This means if you want to bring the charge Q0 from Q point to P point, you are trying to bring the charge Q0 from Q to P. You have to perform some work, or charge has to perform some work, but the distance is very small, so work done will also be small. So work done in displacing the charge from Q to P. You are observing force and displacement are quite opposite to each other. So angle between them will be 180 degree. So it becomes F dr. Now to find the net work done from infinity to P, you have to integrate it. Substitute the value and this is the value of F. This one is dr. Negative sign is there. Now you take the constants outside and integrate it. Where from? You are taking infinity to P. That means your distance will be infinity to R, because you have to bring up to P. Integrate this value you will automatically get, after integration, you will get its value. We are using this formula to integrate. This will come after putting the upper limit as well as lower limit. The final formula comes out to be, this is work done from infinity to P, which is also known as potential energy at P. So this is becomes your final formula This is the electrical potential energy, because 1 by infinity will be taken as 0. This will come while you are substituting the value. The same thing, if you will go one more step, it will come out to the potential of that one. Suppose you want to find out potential at P. I told you earlier, I explained it, that net work done divided by the test charge. Test charge means the charge which you are bringing. If you will divide that work done with the test charge, it will automatically becomes potential at that point. So on substituting the value and dividing by Q, you will get, this is the electric potential of P. The unit will be joule, this will be unit joule per coulomb. Both are scalar quantities, so you need not to think about the direction. Potential, electrical potential energy, both are scalar quantities. Now to solve the numerical related to potential energy and electric potential. We have a numerical here. This is a square, and on the vertices of the square there are 4 charges, respectively plus 2 microcoulomb, plus 4 microcoulomb, minus 2 microcoulomb, plus 3 microcoulomb. Side is 20 centimeter. Let us take to be A. Now our question is to find out either potential energy may be asked to you at A, at B, at C, at D, or question can be asked to you at O, where O is the intersection point of the 2 diagonals of the square. But remember, the charge is not given at O. So try to understand first that whether you will be able to find out or not. Potential energy require both the charges. As you know from formula, potential energy depends on source charge as well as test charge. So first of all, you will find out potential energy at A due to B. How will you find out? Potential energy at A due to B, 1 by 4 pi epsilon naught charge of A, which will serve as test charge, charge at B known as source charge, and the distance between A and B. Since it is a scalar quantity, so no other direction is required. This will give you potential energy at A due to B. But remember, this is not the answer, because you have to find out net potential energy, and in the neighbor there are 3 other charges. So first of all you will find out due to B, then at A due to C, then at A due to D. Similarly you can write charge at C, charge at A by R AC. Similarly substitute here for charge at D, charge at A by R ED. You substitute the value, it is in microcoulomb, so you know the meaning of micro, 10 to the power minus 6 coulomb. So charge at B will be 4 into 10 to the power minus 6 microcoulomb. Charge at A 2 into 10 to the power minus 6 microcoulomb, and this BA means 0.02 centimeter, because this one is 20 centimeter. So A means AB, BC, CD, or DA or AD, all are equal to A, that is 0.2 meter. You can find out AC or BD. In a square, this will be right angle. So this is square, plus this square will be equal to this square. So AC or BD will be equal to A square plus A square. That means it will be A root 2. So this distance becomes 0.2 root 2 meter, the diagonals. So you can substitute the values, and according to that, to find the net potential energy at A, you just add the rest. This is called superposition principle. Simple algebraic sum, you can also say that potential energy at A will be equal to A due to B, at A due to C, at A due to D, and sum total of all these will give you the net potential energy at A. You just substitute the value only, right? So this is the potential, net potential energy at A. Similarly, at B, you will find out at B due to A, due to C, due to D, add them to get at B, C and D. But when anybody asks me about potential energy at O, you cannot say potential energy at O because it requires the test charge also, and the test charge is not given at O. So you cannot say about this one because here test charge is missing. You can say electric potential at O, but you cannot say potential energy at O till you are not taking unit positive charge there. Okay? So test charge is required in case of potential at O. So this is about the potential at A, B, C and D. But suppose that charge here is given as plus 2 microcoulomb. Now we are providing the charge at O. Charge at O becomes plus 2 microcoulomb. Then in that case, we can be able to find out the net potential energy at O. How? First of all, we will find out potential energy at O due to A. So just change. You have to find out potential energy at O due to A. You are bound to take the potential energy. For potential energy, you require charge at O, charge at A, and the distance will be from O to A. Right? Similarly, at O due to B, and this becomes OB. Similarly, at O due to C, and D is also required. So potential energy at O due to D, 1 by 4 pi epsilon naught, charge at O, charge at D by ROD. Since you are well known the AC, you are knowing about the value AC. So from AC you can go for OA, OB, OC, etc. OA, all will be equal. Let it be R. This will be equal to half of the diagonals. So this becomes 0.2 root 2 by 2. Now this is what you require. Now you have to find out net potential at O. So simply potential at O due to A, due to B, due to C at O plus due to D at O. You add them to get the potential energy at O. But remember that if test charge is not given at all, you will not calculate that part. Similarly, we can go for electric potential. If anybody asks you to find out electric potential at O, then you know from the formula that electric potential only requires source charge. Requires source charge. It does not depend upon the test charge. So, if anybody asks you to find out electric potential at O, no problem. Directly divide the potential energy at O by the test charge at O. This means the net value, whatever the net value comes after adding, you divide it by plus 2 microcoulomb charge. That will be automatically electric potential at O. If anybody asks you to find out electric potential at A, at B, at C, at D, at O, then what will you do? That means this time the person is not asking about potential energy at A. He is directly asking about potential energy at A, B, potential at A, B, C and D. At the same time at O. No problem at all. Potential at A due to B, first of all, you have to find out net potential at A. Again, several charges are there. So according to that, you have to take. So potential energy at A due to B charge. At this charge, first of all, you take potential due to this charge. That means this becomes test charge and this becomes source charge. And you know potential depends upon source charge. So you will take 1 by 4 pi epsilon naught charge at B by distance of B from A. Similarly, you can go for potential at A due to C. Charge at C by RAC. Similarly, you can go for D, only 3. If this time, if test source charge or a charge at O is given to you already, then that will also apply electric potential at O. So this will also be taken into account. Charge at O by charge at D by R. Now, these are the potential due to B at A, C at A, D at A and O at A. You have to find out net potential. Net potential at O, that means it will be sum total of, net potential at A. It is sum total of A due to B, potential at A due to C, A due to D and A due to O. This means this electric potential will be sum total of these. Just calculate and add them together. You may take a shortcut method also. You can directly take 1 by 4 pi epsilon naught common. You can put charge at B by AB, charge at C by CA, charge at D by DA and charge at O by A. But remember, if you are using this formula, the charge must be negative or positive, whatever given to you. If the source charge is given as positive, you take plus 4. If it is given minus 2, you take minus 2. Don't take only 2 microcoulomb. Don't take only magnitude. You take here along with the nature of the charge, plus or minus. You just put it and the final answer will be